You are watching the 8.2 lesson video on solving systems graphically, day 1. Looks like we're just going to dive right into some examples today because I think that in order to find the best use of our time, that's exactly what we're going to do. So the directions say to solve each system of functions below graphically. And later this unit we're going to talk about algebraically, and yes, there is obviously a big difference between the two of them. So if we look at example number 1, we're starting off pretty basic, and you should definitely be using your straight edge. Unfortunately, with this program, I cannot use a straight edge, but you definitely will be when you do these notes. So with example number 1, we have two functions, f of x and g of x, and as you can see, they are both linear functions. So instead of showing a table of values, I am going to just write out what the y-intercept is. So my starting point is always my constant, so 0, 4, and my slope is -2, which I'm going to write over 1. So what that means is I start at 4 on the y-axis, and I go down 2 and to the right 1. So let's go ahead and do that. So we start at 4, down 2 to the right 1. And we continue this pattern to cover the entire graph on both sides. So even though we are working to the right, we can also follow the pattern backwards and cover the graph to the left. Now using our straight edge, which I cannot use, you're going to connect those points together. Now, I also put arrows on the ends of my lines, and because I'm going to be graphing multiple functions on the same graph, it's actually really important to label. And I don't have to label it with the entire equation right now because it is labeled f of x already, so as long as I label it f of x, I'm good to go. Let's do the same thing with g of x, and I'm going to use a different color because I think it just helps me to see things and you to see things a little bit better. All right, so you know the drill. We don't have to show a table of values because this is a line, but we do need to show our work that our y-intercept is at 0, -3, our constant, and our slope is 1/3, which means up 1 to the right 3. So 0, -3, and then we're going to follow the pattern up 1 to the right 3. Nice, it intersected right away. Doesn't always happen that way. And we're going to keep graphing down 1 to the left 3. We always want the points to just cover that whole graph. That way when we use our straight edge, it's really easy to match everything up. And again, we use a straight edge, we use arrows, and we label. Now, believe it or not, a lot of people forget to actually answer the question when you're solving these. So right away, everyone's like, yeah, I drew a great picture. I'm so excited, and they move on. Well, the only problem with that is you never told the person what the solution actually is. So what is the solution? Well, you know that. It's the point of intersection. So let's write that out down below. The solution, which is obviously the most important part to this question because it's the answer, is the point 3, -2. And I'll put that in a bubble just so we can show the reader how important it is. Now, when you're taking a test, what I would strongly recommend is that before moving on to the next question, or if you would rather do your checking all at the end, that's fine too, but we should definitely be checking our work. So take a minute right now, pause the video, and graph these two functions and find the point of intersection, just like what you did in Unit 1, or Lesson Video 1, I should say. You can see my check off to the side that, yes, I was correct because I found the intersection point to be the solution 3, -2. So we are actually going to skip question number 2. Of course, we're still going to do this. We will do it together in class when I see you next. Let's move on to question number 3. So number 3 is a system, and this one is a little bit different because we have a system of inequalities. Notice how we do not have equal signs. We have greater than or equal to symbols and a less than symbol. Remember, when we graph inequalities, we graph them the same exact way that we would graph a line. So we still have a y-intercept. This is no different than our first example. We still have a slope, -2/1, which means down to the right one. But we have to give this a little bit more information. And I'm really happy that this has y alone on the left-hand side, because now I can actually use the rule of all the things that we've talked about with this inequality symbol. So the first thing that we need to talk about, or there's actually two things we need to talk about: shading and whether or not the line is solid or dashed. Those are usually the mistakes that people make when you graph inequalities, so we're going to be very careful not to make mistakes or forget about it. So the first thing that I notice is a greater than symbol. So since it's greater than, we will shade above. And let's write out all this work. And since it's equal to, the line is solid. Okay, let's graph. So 0, -9. We're going to go down to, uh-oh, I can't do that. So instead I have to go up to the left one, opposite of both. Remember, if it's a negative slope, the line should be pointing downward. That's a mistake that I see a lot when we run out of space, when we try to move to the right. So just be mindful, be mindful when you are working through. Okay, now we need a solid line with arrows, so use your straight edge. And do not forget that we need to shade above the line. And shading above does not mean go crazy and color everything in. I just like to draw my shading like this. All right, let's move on to y is less than 3/4 x plus 1. Ooh, before I do that, what did I forget to do? Yes, I forgot to label. So go ahead, make sure you label your inequality. So next we need to graph our second inequality. The first thing that I'm going to do is look at the y-intercept. That's at the point 0, 1, which I get from my constant here. And then my slope is whatever number is in front of the x, the coefficient in front of the x, which is 3/4, which means I go up 3, to the right 4. Let's go ahead and plot that. So there are my points. What I need to do now is figure out what type of line I need. So this is less than. It's not less than or equal to. So this symbol here, this less than symbol, means that I shade below. But since it can't equal, we have to make sure that our line is dashed. So here's the graph of my second inequality. Notice how my line is dashed and that I've shaded below the line. And remember, we don't go crazy with the shading. I know that some people want to just like color every box in. Please don't do that, because now you can see the nice crisscross overlap of the two functions. And that is actually what we consider the solution to the inequality, and we're going to put a giant S in there. A couple things to point out: every single point that is inside the shaded area where the S is, those are solutions. The point where the two inequalities intersect in this problem in particular is not a solution, only because, not because it doesn't intersect at a nice integer point. It doesn't matter. It could intersect at a fraction point as long as the two lines are solid. But one of my lines here is dashed, which means it can't equal. So right away we know that the point can't be a solution just because it can't be a solution to my bottom inequality of y is less than 3/4 x plus 1. Okay, so let's take a look at example number 4. It looks like we are graphing a linear and a quadratic system. So the line is pretty self-explanatory and straightforward. It's the same as we've been doing. We have a y-intercept at 0, -2, and the slope here is -1, so -1 over 1 means down 1 to the right 1. So let's take a look at the graph for a minute. One thing that I immediately notice when I plot my y-intercept is that my scale is a little bit different than all the other graphs. My y-scale is actually counting by 2's. So using my slope of -1, 1 might not be the best. I could make this a little bit better. I could scale it and say, well, going down 1 to the right 1 is the same as going down 2 to the right 2. So that might be a little bit easier to plot these points, but also recognize that this point, the halfway mark, oops, this also exists on the graph as well. So there, 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 and it looks like halfway. That's actually, though, negative, let's see, this one's -3, -5, and so on and so forth. So we want to graph the nice points, but also remember that those halfway points are still nice integer points. Okay? Straight edge, arrows, label. So here is my linear function, f of x. And now I need to graph my quadratic. And in order to show work for my quadratic, I need to show a table of values. So let's set up our table of values over here. And in order to get this table, well, I'm going to graph, I think I already have this pulled up. Yep, so you're going to graph this. And I had to change my scale a little bit because when I first graphed it, it looked something like this. And I like to see the vertex, so I can see where the vertex is happening. Look at Control T, and you can see that it's happening, well, we look for the repeating points. So I'm going to stop the video and I'm going to write out the table of values, and I'm going to warn you, I think we have to, yep, we're going to go from -4 and pretty high. So there's going to be a lot of points in our table of values, but make sure that you have the point to -16 in there because it is the vertex. Okay, I told you it was going to be long. So here is my table of values. Please make sure that yours matches up with mine. Next, I want you to plot all of these points, and yes, I know that some of these points are not going to happen at the nice intersections on the graph, but that's okay. We need to be a little bit careful because of the scale on this one. So go ahead and plot all those. I don't even know how many points it is, but all of them should fit, believe it or not, except for the last one. So here we have a picture of our two functions, both labeled, and what we still need to do, of course, is state the solution. So we need to either find a point of intersection or points of intersection, and that's actually happening in two spaces, here and there. So off to the side, let's actually write off, or let's write solution. In this case, it's solutions because there's 2 points. And this happens at the point -2, 0. And this one is a little bit trickier to see, but we do have this point of 5, -7 plotted on the line. And as you can also see, it's in the table of values below. Now, if you weren't sure, what you could always do is just verify using your technology and graph both of the functions and make sure the two points intersect together. And by points, I mean lines, functions, I should say, because one's a line and one's a quadratic. And I would also like to save question number 5 for in class. So you are done with this lesson video.